Hi, my name is Masood. This video is to provide training for UIT students for electric machine lab as well as electromechanical energy conversion lab. In these labs we are using the systems from a German company called Lucas Newly. The system is called Unitrain systems. It includes a USB interface and it includes a couple of experimenters unit that are identical and they are connected to interface units. The experimenters are used to have the boards inserted inside. For each experiment we have one board. For example, for auto transformer we have one board that could be used to do variety of experiments with auto transformer. In order to insert the board inside the experimenter, you start from here and you gently just pull the slot on the side and you just insert it. You gotta make sure that you hear the click sound at the end, so this way you are absolutely sure that the board is all the way inserted and connected. Then what you need to do, you have to run the LabSoft in order to connect to the module and in order to find out about the experiments and the wirings. The experimenter has two analog input which you can consider to be as two channels of the oscilloscope, channel A and channel B, and one analog output which you can consider to be as a function generator. And you can use the software which is called LabSoft to control the analog input and analog outputs. So to run the LabSoft, you go to programs and you can search for LabSoft and then you can run it. The first like your window is asking which language, choose the English. First it's asking for a name. You can just put your name there. For example, I'll put my name here, Masood, or you can put your student ID. For password, just leave it as blank and then say OK. It's going to ask you that this account has not been registered yet. Do you want to create it? You just say yes. And because we are doing electric machine, we just choose the electric machine labs and it comes. Because the unit is not on, so you have to run the program in the simulation mode first to do the wiring, and then you have to turn the unit on and run it in connected mode. So first I'm running it in the simulation mode. Experiments are popping up here. So the first experiment, let's say, is the three-phase transformer. I want to expand the three-phase transformer here, and you can see that for three-phase transformer, again I have to say run in simulation mode. The training objectives, you can see the training objectives here. You can see the equipments that are going to be used, which is the board that I already mentioned and we inserted into the experimenter. Experiment cards, the technical data for experiment card, and then the variety of experiment. Let's say I want to do the first experiment, which is experiment no load response for the single phase transformer. So I click on the experiment. This is the wiring diagram, and then you can see an animation of the wiring. I can just fast forward to see all the wirings here, and this is what I have to do using these wires here. So the wires are used to connect the thing. So let's say I'm going to do just a few of them. Here on the wiring diagram it says the A plus is connected to the little board, and the little board that we have here is a resistor load board to measure the current. So this is our little board. So I am going to insert it inside the unit experimenter. So I'm inserting this unit here, this resistor load board, and then I am going to connect channel A plus to the same pin which is shown on the wiring diagram. Next, I can see that the A minus is connected to the next pin, to the side pin. So I am going to connect it the same way. So A minus is connected to another pin. So this way I can complete the wirings based on the wiring diagram to finish all the wiring. Just don't forget, please, connect any jumpers. So you see this white jumper on the diagram, so that would tell you that these two pins are supposed to be connected using the jumpers. So I'm going to connect the jumpers now. So jumpers are connected this way. So do not forget the jumpers. When the wiring is finished, now it's the time to turn on the unit. To turn on the unit, there is a switch on the back that you have to turn it on. Before you turn the switch on, you have to close the lap soft completely. So I'm going to close the lap soft. So lap soft is closed, and then I'm going to turn on the unit. So I'm turning the switch on and make sure the power is connected. So when the power is connected, you see the orange light here. It takes a while for the orange to turn into green. This means that the unit is connected through the USB cable, and then this is the time to run the lap soft. This is a complete wiring of one of the experiments based on the lap soft diagram. When the wiring is complete, you need to close the lap soft. You need to turn the power switch on the Unitrain system on so that you see the green light on, and then you have to go and run the lap soft again. So I'm gonna open the same account, electric machine courses, maximizes the window. I'll go to the experiment, which was the 3-phase transformer, the single phase version, and the experiment no load response. So that was one of the experiments that we already started, and you remember that we had all this wiring completed. So the next step, it says open the 3-phase power supply virtual instrument, and this is the power supply virtual instrument. Good thing about laptop that is that when you click on the picture, the instrument interface is gonna pop up. So look at the table for the setting. It says frequency 50 Hertz, so you change the frequency here to 50 Hertz. And then it says the amplitude 12 volt, so you change the AC voltage to 12 volt. And not until you click on this button, which is the power button, is the power supply is not going to be on. So I'll keep it here. I'm not going to turn it on now. I'll go to the next step, which says open the virtual instrument ammeter A. So this is the multimeter or ammeter A. So look at the setting. It says range 500 milliamp. The range is 5 amp now, so I'm gonna just lower the range to 500 milliamp. It says AC. This is DC now, so I'll click on the AC so that the multimeter is gonna measure the AC. It says the mode is RMS. As you can see, the arrow shows RMS, but let's say if it was here on like PP, then you had to change it to RMS by clicking on RMS. And then there is something which is called a setting that says Shunt Resistor 1 ohm. So Shunt Resistor is this resistor, and actually it is the resistor that we have here on the So on this part, this is the shunt board that is used to measure the current. So the concept is that when you pass a current through a 1 ohm resistor, the voltage across resistor based on the Ohm law is going to represent the current. So the shunt board here is going to be used to measure the current in the Unitrain system. So here we have to set it to 1 ohm because the default is 10 ohm. So just click here and type 1 ohm and say OK. So the shunt resistor is now 1 ohm, so the measurement is going to be shown correctly. So I'm going to just go bring this here, and then the next step is saying that what is the no load current I naught. So I naught needs to be measured by this current meter, so I have to turn this power supply on first, and when I turn this power supply on, and again I think it was 500 milliamp range, so I can read 143 or 102 milliamp here. So I have to enter 143 milliamp as the answer. And good thing about LabSoft is that you can check your answer. So if you click on check answer, you see that it says correct here. So in this way you can check your answer to be correct or not. If the answer is not correct, then either you don't have a correct wiring, or there is something not connected to the power supply, the range or the settings might not be correct. So there are a lot of like parameters that may lead to a wrong answer. So this is your responsibility to find the other one. And then the next step, for example, says open the voltmeter B. So again, clicking on the voltmeter B, you can set the 20 volt AC. So again, this has to be AC, this has to be bring down to 20 volt, the range. RMS is okay, so it means that the voltmeter B is correct, and you can read 12.6 volt here as the no load voltage. So I'm going to just enter 12.6 volt here, and I'm going to say check answer, and again you can see that the answer is correct. So this is the way that you read the voltage and you measure the currents and voltages in Unitrain system. So now I'm going to close the mirrors, and then next step is saying that use the oscilloscope. So if I click on the oscilloscope here, the oscilloscope is going to be popped up. So it says the channel A setting is 200 millivolts, so it's 100 millivolts now, so I'm going to put the settings for 200 millivolt. You can see that channel B is here, channel A is here, and it's AC, so it's already AC, so it's okay. For channel B is 10 volt, right now it's 5 volts, so I'm going to change it to 10 volt, and it's going to be AC again. And the trigger is on channel A, so trigger is channel A. I set the trigger to channel A, and time base, which is here, should be set to 10 millisecond. So when I do that, I can see the voltage and currents, because if you remember, channel A was the current and channel B was the voltage. So current and voltage signals are going to be shown, displayed on the oscilloscope. And if I just simply drag this here to this, you can see that this waveforms were simply copy pasted here. So this means that in LabSoft you have the luxury and the option to just capture the signals on the oscilloscope and create your reports. So as you go, you can see that the report is generated here. So I'm going to turn off the power supply, and I'm going to close it because I don't need it now. So all the answers and graphs and everything are going to be copied in the LabSoft report. In order to create and finalize your report, let's assume that the report is final here for this experiment. You just simply go to File, to Print, and you have an option to print to PDF for PDF. So you just print this report to a PDF file. You can simply say print. It's going to ask you for a location, save as PDF, and you just define the location, which is better to be your flash memory, so you can save your report and you can submit your report to the lab instructor as you go. So this was a general overview of how LabSoft is working, how the virtual instruments are working, how the oscilloscope is working, what's the measurements of current and voltage, how it is done in LabSoft. And I hope this was helpful for the students at UIT, so that you could use it for electric machine, energy conversion, and other courses that use Unitrain system. Okay, thank you very much.